Students, so far we have seen part 6 up to part 6 video we have seen. Okay, one more time we'll recall what are the chapters and what are the topics we have learned, we'll discuss. Students, so far we have revised chapter 1 real numbers, isn't it? In the real number, first topic we have seen about Euclid division lemma. Then afterwards we have seen about Euclid division algorithm, and based on this two theorem we have done some problem, isn't it? Then afterwards, next what we have seen? We have seen about fundamental theorem of arithmetic. We have seen, isn't it? Based on that, we have found the prime factor of LCM and HCF. We have found and we have did in that exercise 1.2. Then afterwards, we have seen about irrational numbers. That everything is full of like a theory part that we have done in previous video, that is exercise 1.3. Students, now in part 7 video, chapter 1 real number we are going to see. In that we are going to see exercise 1.4. With this exercise 1.4, our chapter 1 is completed. Okay, now before entering into exercise 1.4, we will have to know some introduction, isn't it? So, we are going to see first introduction, then only we are entering into exercise 1.4. In this exercise 1.4, we are going to learn about terminating and non-terminating. Two terms we are going to learn. The first term is terminating and the second term is non-terminating. Let us see what is terminating and what is non-terminating. Okay, now we will enter into the video now. Students, rational numbers are classified into two types. The first one is terminating, the second one is non-terminating, repeating, recurring. Okay, you can say it as non-terminating, repeating, or non-terminating, recurring. You can say anything, you can say. Okay, so what do you mean by this term terminating? Means if you are dividing 5 divided by 2, what will be your answer? You will get exactly 2.5. In the remainder part, what you will get? You will get 0. Then this number is called terminating. Okay, at the end you have to get 0. Okay, with this number is called terminating. Non-terminating, repeating means when you are dividing any number, by the time you will not get the remainder, it will goes on, isn't it? If the same number sometime will repeat, isn't it? So that number will say it as non-terminating and repeating, or non-terminating and recurring, we can say. Clear all of you about terminating and non-terminating? Okay. Now we will see the example. This term rational numbers and irrational numbers we will see. Where this terminating and where this non-terminating will come, we will see now. Now we will see this example. Now we can see the example. Example 1.2 terminating. I have written 1.2 terminating. Why means 1.2 afterwards no number will get, which means what? The remainder will be what? 0, isn't it? So that number will say it as terminating. Suppose if you see here 1.2, 1, 2, 1, 2, 1, it goes on. We never get end point. We never get remainder. The remainder is 0. So the same number repeating and we are not recurring means what we have to write? Non-terminating and recurring. You have to write. Okay, if the same number is repeating and we are not getting remainder 0, it's going on means then it is what? Recurring. Clear? So it is what? Non-terminating, repeating, you can say, otherwise non-terminating, recurring, you can say. Clear? These two category will come under the rational numbers. Okay. Now, irrational number means what? If this rational number I have told you before itself, rational number can be written in the form of what? P by Q, isn't it? Rational number can be written in the form of rational numbers can be written in the form of P by Q, where denominator part Q should not be equal to 0. I told you, isn't it? So this two number we can write in the form of P by Q, isn't it? So if you come to irrational number, we cannot able to write in the form of P by Q. We cannot able to write in this form. So if you see if you see that example 1.2123483598, it's still going on, but the same number is not repeating, isn't it? If you see here 212121, the same number is repeating. So we have written non-terminating and recurring. But if you see there, the same number is not repeating, but it is going on, which means that category will come under non-terminating and non-repeating. Clear all of you? This term will come under non-terminating and non-repeating. Okay. Students, in this chapter 1, real numbers, before entering into exercise 1.4, we have two theorems. The two theorem, what it says means, the first theorem is theorem number 1.6. Let x is equal to p by q. P by q means what? P denotes numerator and the q part denotes the denominator. X equal to p by q be a rational number such that the prime factorization of q. Prime factorization of q means what they are saying? The denominator part. Okay? The denominator part alone you have to do prime factorization. Okay, the prime factorization of q is in the form 2 power m into 5 power n. Yeah, nothing is there in between, means you have to consider it as into. Okay, so 2 power m into 5 power n, where n and m are non-negative integers. Okay, it should not be negative, non-negative integers. Then x has a decimal expansion which terminates. This theorem says. What this theorem actually says, isn't it? If you see this example, 3 divided by 20. What they are asking to take? They are asking to take prime factorization of the denominator. Isn't it? That only they are saying. Prime factorization of q. Q is nothing but what? Denominator. Okay. When we are taking the prime factorization, if you see here, 4 5s are 20, 2 2s are 4 and the last remainder is 1. Okay, how can I write this 20 now? 5, how many times I have got? 1 time. So, I have written 5 power 1 into 2, how many times I have got? 2 times. So, I have written 2 square. When you are doing the denominator part factorization, by that time the denominator has to get in what form? 2 power m into 5 power n, you have that form you have to get. Now, if you see we are getting in that form or not? Yes, we are getting. Even it is what? 5 power n into 2 power m. 2 power m into 5 power n are what? Both are same only. We are getting in the form. Therefore, this 3 by 20 is what? It is terminate. We have to write. Clear about this theorem? Okay, we will see the next theorem. Theorem number 1.7. Okay, now the next theorem is theorem number 1.7. So, in this theorem, what they are saying is, let x is equal to p by q be a rational number such that the prime factorization of q is not of the form. What they are saying? Prime factorization of your q. The denominator part is not of the form 2 power m into 5 power n, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating or non-terminating recurring, we can write. Students, what is the difference between theorem 1.6 and 1.7 is, if you see in exercise in theorem 1.6, the denominator part, it should be in the form of 2 power n into 5 power n. Then we will say that expansion is terminating. Okay. Now, if you see in theorem 1.7, they are saying that the denominator part q should be not in the form of 2 power n into 5 power n, which means not in the form means then the decimal expansion is non-terminating repeating or non-terminating recurring, you can say. Clear the difference between the theorem 1.6 and 1.7? Okay, if we do the problem means it will be more clear. Let us see now the example. 5 divided by 3. Students, if you divide 5 by 3 means what we will get the answer is 1.66666666. It will goes on. Okay, never in any point it will get 0. Okay, always the remainder will be 6666. It will goes on. So what they are saying? We are not arriving at 0. Then this is what? This is non-terminating, recurring. Recurring meaning is what? Repeating. So it is non-terminating and recurring. You have to write. Clear? Because why? The see your q is not in the form of 2 power n into 5 power n. Students, you see here, wait, what is the denominator part? 3 we are having. Students, will you able to write that 3 as 2 into 5? We cannot able to write. What they are saying? Q is not in the form of 2 power n into 5 power n. So we are not getting 2 power n into 5 power form. Isn't it? So this is what? Non-terminating and repeating. Easily we can see. Without dividing, we can say easily whether it is terminate or non-terminate. Clear? Similarly, you see the denominator part alone you see. If you see the B example 6, whether can I write 6 as 2 into 5 can I write? We cannot able to write. So, I can see directly, I can say that the 17 divided by 6 is what? Non-terminating recurring. I can say without dividing. Clear all of you? Similarly, you see the denominator part of 7. We are having. Whether you can write some 2 into 5, 7? No, we cannot able to write. So by seeing itself, we can directly say that it is not terminating and recurring. Students, clear all of you? Based on this two theorem only, we are going to do the exercise 1.4. Okay, now we'll see exercise 1.4, problem number 1. Students, now we are going to see exercise 1.4, first question. Okay, in the first question, we are having 10 subdivision. Okay, I will do you some of the problem and what are the problems I am not doing, that's your homework. Okay, students, this is very simple and very easy. Listen to the video carefully. What is the first question heading is, without actually performing the long division, state whether the following rational number will have terminating decimal expansion or a non-terminating repeating decimal expansion. What they are saying is, students, the 30 divided by 3125 they have given. They are saying no need to divide actually. If they are given like this means how will you do normally? How we will do? We will divide 3125 by 30, isn't it? They are saying you no need to divide. Normal division they are not asking. They are asking without dividing. We have to say whether it is terminating decimal expansion or non-terminating decimal expansion we have to say. Clear? So, for that only we have seen two theorem. Theorem number 1.6 and theorem number 1.7. Okay, one more time we will recall. What theorem number 1.6 says? Theorem number 1.6 says, if the quotient, if the q or if the denominator part is in the form of 2 power m into 5 power n means that the decimal expansion is what? Terminates. Suppose, theorem number 1.7 what it says? If 2 power m and into 5 power n, the denominator part does not contain 2 power m into 5 power n means then the decimal expansion is non-terminates and repeating. Clear? These two things only we have learned in theorem 1.6 and 1.7. The same thing we are going to apply here. Without dividing, we are going to just simply, we are seeing the denominator, we are going to say whether that term, that the rational number is terminates or non-terminating, we are going to say. Okay, now we see the first question. Okay, 13 divided by 3125. The question is what? 13 divided by 3125. Students, our first step is you no need to see numerator part at all. Okay, for any problem you no need to see the numerator part at all. You have to see only the denominator part. Okay, what is your denominator part? 3125. Students, you have to take LCM. Okay, prime factors only, prime factorization we have to do. So you see here I have done here prime factorization. So after doing, you see 3125, how can I write? 5 into 5 into 5 into 5 into 5. So totally how many 5 are having? 1, 2, 3, 4, 5. So I can write 3125 as 5 power 5, isn't it? If you see here, I have written 5 into 5 into 5 into 5 means what? 5 power 5 we can write. Okay, what is our first condition? We have to get 2 power m into 5 power n, or otherwise 5 power n into 2 power n. Both are same only. Okay, so we have to get, I have got only 5 power 5. But I am not getting here 2. Students, if you are getting only 5, then it is terminating. Similarly, if you are getting only 2, then also it is terminating. How it's terminate means, listen, we have got only 5 power 5, okay, into what I have written 2 power 0, because we have to get 5 power m into 2 power n form, isn't it? So I need one 2, for that I am writing 2 power 0. Students, you all know in 8th standard you have learned the exponents and power chapter, isn't it? In that chapter you have one formula, a power 0 is equal to what? 1. So any number power 0 is what? Answer is 1, isn't it? So 2 power 0 answer is what? 1. So 5 power 5 into 1 is what? Same 5 power 5 only. Okay, to get in the form of 5 power m into 2 power n, we are writing 2 power 0. Clear all of you? So this 2 power 0 will not make any difference. The same 5 power 5 only. Clear all of you? The numerator part you have to write as such, 13 divided by 3125. When you are factorizing, we have got 5 power 5. Okay, but we have to get into 2 we have to get. Since we don't have 2, we itself writing 2 power 0, because 2 power 0 is what? Nothing but 1. Okay, so to get in the form, we are writing like that. As the denominator, now see the denominator part, as the denominator are in the form 2 power m into 5 power n, isn't it? Clear? 5 power 5 into 2 power 0 or 2 power m into 5 power n, both are same only. How both are same? 5 2s are what? 10. Similarly, 2 5s are what? 10. So in multiplication, if both the number, if you change also, you will get same answer. So the denominator part we arrived in the form 2 power m into 5 power n. Therefore, this question 13 divided by 3125 as terminating decimal expansion. Okay, without dividing we have said, isn't it? 3 as terminating decimal expansion. Students, second sum is your homework. Now we will see the third question. 64 divided by 455. Okay, now you will see the solution. What I told, you no need to see the numerator part. Only we have to see the denominator part. So 455 we are doing the prime factorization. Okay, when you are doing, we are getting what are the things we are getting? 5 into 7 into 30. But what form we have to get to terminates? What form we have to get? We have to get 2 power m into 5 power n. Students, whether you are getting that form? No. We are getting only 1 5 and we are getting only 1 7 and we are getting only 13. So we cannot able to write 2 power m into 5 power n form. Okay. So as the denominator are not in the form 2 power m into 5 power n, so the decimal expansion, the question. So the decimal expansion of 64 divided by 455 is what? Non-terminating repeating. Students, clear all of you? The difference between the first question and third question? Clear? When the denominator part, if you are able to write 2 power m into 5 power n means, then the question is what? Terminating. If you are not able to write in the form 2 power m into 5 power n means what? It is non-terminating repeating. Clear all of you? That's the difference between the first sum and third sum. Okay. Now I erase fully. Now we'll see the remaining problems. Clear all of you? What are the problems I have done? That's you have to copy in classwork. Not done problem. That's your homework. Now we'll see the fourth question. Fourth question is what? 15 divided by 1600. Students, if you are able to cancel both numerator and denominator means you can cancel it. So if you cancel this, both I have cancelled in 5 times. This is 3 times in 5 table. How many times 15 will come? 3 times 3 5s are. So similarly, this if you divide with 5, you will get 320. So afterwards, you have to do the LCM of 320. So if you see the prime factorization of 320 is how many 2 we are getting here? 6 2 we are getting and 1 5 we are getting. So we can write 320 is equal to 2 power 6 into 5 power 1. Students, I told you if it is in the form of 2 power m into 5 power n means what? It terminates. Okay, so as the denominator are in the form 2 power m into 5 power n, isn't it? See here 2 power m, instead of m any number you can, non-integer any number you can take. Okay, it should be a positive number, but any number 2 power 22, 2 power 32, 2 power 46, like that. M and n, this m and n can come any number. Okay, so therefore 15 divided by 1600 has terminate decimal expansion. Why terminate? Because it is in the form of 2 power m into 5 power n. Therefore 15 divided by 1600 has terminating decimal expansion. Clear? Now if you see the sixth question, 23 divided by 2 cube 5 square. Students, if you see in the fourth question, the denominator part we have to factorize and we have to bring it in this form. But if you see in the sixth question, they itself are factorized and they have given the solution. We have to find whether it terminate or not terminate. Okay, on as the denominator are in the form what? We have 2 power m into 5 power n. The question itself in the form. So we have to just write as the denominator are in the form 2 power m into 5 power n. Therefore 23 divided by 2 cube into 5 square as terminating decimal expansion. Okay, in this we no need to calculate anything because they itself are calculated and have given the question. Clear? Now we'll see the eighth question. See here both will 6 divided by 15. Both will go in what table? 3 table. In 3 table 6 how many times? 2 times. Similarly in 3 table 15 how many times? 5 times. So now our question is what? 2 by 5. Okay, so I have written 2 by 5. So I have only 1 5. So I can write the denominator is only 5. So I have written 5 power 1. Previously I have told you what is the value of 2 power 0. Since the value of 2 power 0 is 1, we all know. Okay, anything power 0 is what? 1. So as the denominator are in the form 2 power m into 5 power n. Isn't it? I told you before itself. 5 into 2 answer is what? 10. Similarly 2 into 5 is what? That also 10. So you can interchange and you can write 5 into 2 or 2 into 2 power m into 5 power n. Both are same only. So to make this form we are writing this 2 power 0. Clear all of you? But our denominator is what? Only 5. To get this form we are writing 2 power 0. 2 power 0 is nothing but what is the answer? 1. So 5 power 1 into 1 is what? 1 only. So no problem in that. To get only in this form we are writing like this. Clear all of you? So now if you see 6 divided by 15 or what form? As in the form of 2 power m into 5 power n. Therefore 6 divided by 15 as terminating decimal expansion. Clear all of you? If you see the last 10th question, 77 divided by 210. So denominator part you have to take the, you have to do the prime factorization. I have done here. See here 5 7 2 3 we are getting. So 210 is equal to 5 into 7 into 2 into 3. Okay, so if you see whether it is coming 2 power m into 5 power n, we are getting 2 and 5, but we are getting extra 7 and 3. We should not get that. So we have to write as the denominator are not in the form 2 power m into 5 power n. So the decimal expansion of 77 divided by 210 is non-terminating repeating. Clear? Students, in first subdivision what we have seen? Whether it is terminating or non-terminating. How will you say it is terminating? If the denominator part comes in the form of 2 power m into 5 power n means it is terminating. If the denominator part is not coming in the form of 2 power m into 5 power n means it is not terminating. Clear all of you? That's the difference. Clear? Now we'll see the second subdivision problem. With that our first subdivision is over. Students, what are the problems I have done? You just copy in the classwork. Remaining problem you do as your homework. Students, in second question, write down the decimal expansion of those rational numbers in question 1. Okay, what is in this? Now previously what we have seen? We have seen the first subdivision. In that first subdivision we have seen 10 problems, isn't it? 10 subdivision we have seen. So in that first subdivision, among the 10 problem, what are the problems we got? Terminating decimal expansion. We have to take that problem as the question for second question. Clear all of you what I am saying? From the first subdivision, we are having 10 problems. From the 10 problems, what are the problems got terminating decimal expansion? That question you are going to take it for the second sum. Clear? So, if you see in the first subdivision, we have got first question we got terminate, second question also we got terminate, third question is also we got terminate, similarly sixth question we got terminate, eighth question we got terminate, ninth question we got terminate. Remaining fourth, fifth, seventh, seventh and tenth we got non-terminate. We have to leave the non-terminate questions. We have to take only the terminates question. That questions we are going to solve in the second subdivision. Clear? If you see in your book, they will not be given these questions at all. Okay, we itself have to take from the first subdivision. Okay, I have taken from the first subdivision. Okay, now we will see. What they are asking here is, we have already proved it is terminating decimal expansion. But they are asking write down the decimal expansion. They are asking the decimal expansion. Okay, so we will now see 13 divided by 3125. That is our first question. Student, listen carefully. This is also very easy question only. So 3125 we have done in the prime factorization in problem 1. One more time I have worked out here. See this rough work you see. 3125 if you do the prime factorization, what we are getting? 5 to the power 5. Isn't it? 5 to the 1, 2, 3, 4, 5. Totally how many 5 we are getting? 5 power 5 we are getting. So what we are doing is we are writing the question. 13 divided by 3125 equal to 13 divided by, when you are factorizing, what you have got here? We have got only 5 power 5. Isn't it? So that only we have got. But why we are multiplying this 2 power 5 and dividing by 2 power 5 means? Because terminating means it should be in the form of 2 power m into 5 power n. Isn't it? We have got here 5 but still we need 2. Isn't it? So whatever the power you are coming, the same power you take value for the 2 also. That number you multiply with the numerator and as well as divide the same number. If you are taking 2 power 5, then the denominator also you have to take 2 power 5. Clear? Here the power is 5, so here also we are taking 5. Okay, we are having only 5 here. Then what number missing? 2 we are missing. So we are writing the base as 2. Clear all of you? So if you see still more problem, you will be very clear. Okay, so I have written here 3125 prime factorization is 5 power 5. To get in the form of 2 power m into 5 power n, I am multiplying 2 up and dividing denominator. Okay, since here we are having power 5, so here also we are writing the power 5. 2 power 5 divided by 2 power 5 we are doing. Afterwards, 13 into 2 power 5 means what? I have written here. This is all since what? If you need for your understanding, you can copy in the classbook in the side. Okay, since I don't have space here, I have written in the top. You can write it in the side of your classbook. 2 power 5 means what? 2 into 2 into 2 into 2 into 2. So totally how many 2? 5 2. So 2 into 2 into 2 into 2. If you multiply, what we will get? We will get 32. So this 13 we are writing as such into 2 power 5 answer is 32. So numerator part we are multiplied. Divided by. So here see here also the power is 5. Here also the power is 5. So we can multiply the base part alone. 5 into 2 and we can write commonly 1 power 5. Clear all of you? So 13 into 32 if you multiply, we will get 416. Okay, divided by 5 2s are what? 10. This power 5. Okay, the next step for 10 to the power 5 means what? 416 divided by, if how many power number is coming, that much 0 you have to put. Since we have power 5, 1, 2, 3, 4, 5, 5 0 we are going to put. Because 10 square means what? 10 square means 100. Or 10 into 10. Square means we are writing 2 0. Like that you think of. Okay, since we have power 5, so put 5 0 and put 1. Okay, so we have to divide. Students, this also we have read it, exponents and power, isn't it? In the decimal expansion and You have learned it. So how we have to write this? See how many zero below we are having? 5 0. So we have to move 5 places before. Okay. So if you see here, if you start from here 1, 2, 3, 4, 5. Keep the dot and before you write 0. So our answer is what? 0.00416 is our answer. Clear all of you? If you see the next question, 17 divided by 8. Okay. If you see in this 8 is what? 2 cube. 2 into 2 into 2 is 8. Isn't it? So 17 I am writing 2 cube. Only you will write now. Then what is our form? Terminate means our form is what? 2 power m into 5 power n. Here 2 we got, but what we are missing? 5. So multiply 5. Here what is the power? 3. So you write 3 power. Clear all of you? So now if you see 17 into 5 cube means what? 5 into 5 into 5. 5 into 5 into 5 is what? 125. So 17 into 125 divided by 2 into 5. This 3 you have to write commonly. Whole power 3. So 17 into 125 answer is 2125 divided by 5 2s are 10 the whole cube. Since we have cube, so how many 0 we have to put now? 3 0 we have to put. And from the last place we have to move 3 place before. So if you see here 1, 2, 3. 3 place we are moving and we are keeping the decimal at 2.125. Okay. Remaining problems we will see now. Now we will see the fourth question. Our fourth question is 15 divided by 1600. I have done here prime factorization. What I am getting is, I am getting 1, 2, 3, 4, 5, 6. 2 I am getting 6 times and 5 I am getting 2 times. So I can write 2 power 6 into 5 square, isn't it? This 1600 I can write 2 power 6 into 5 square. Students, what I told, what power you are getting for, you have to see among these two which is the highest power, 6. So that power you have to get for 5 also. So that only you can combinely write 2 into 5. Isn't it? If the bases are same, the power can be added. If the powers are same, the bases can be multiplied. This you have learned in exponential power in 8th standard, isn't it? The same thing. If here you are having 6, then 5 for also you have to get 6. But you are having only 2. To get 5 power 6, what you have to do is, you have to multiply 5 power 4 and divided by 5 power 4. Why means, here also base is 5, here also base is 5. So, if you add this power, 2 plus 4, what you will get? 6. So, here also you are getting 2 power 6 and here also you are getting 5 power 6. So, to get both the powers same, we are multiplying 5 power 4 and we are dividing the same 5 power 4. Clear all of you? Why we are getting multiply and 5 power 4 and why we are doing 5 power 4? Okay, since highest power is 6, for that power you have to get for 5 also. But we are having only 5 square. Still to get 6, how many we need? 4. So we are multiplying that 5 power 4 and we are dividing the same 5 power 4. Okay, so 15 into 5 power 4 means what? 5 into 5 into 5 into 5. So we have to multiply 4, 5. If you are multiplying, what you are getting? 625 divided by 2 power 6 into 5 we are writing. Here how many 5 we are having? 2, 5. So if the bases are same, the power should be added. So 2 plus 4 is what? 6. So we are writing power 6. Clear? At last what? Here also we got 6 and here also we have got 6. So we can directly write 15 into 625. If you multiply, you are getting 9375. So 2 into 5 is what? We can write 2 into 5 and the 2 power we can write commonly as 1 power 6. So I am getting 10 power 6. So I told you students, if 10 square means you will put 100. Isn't it? Similarly, we are having 10 power 6. So you allot 60. Okay. Then how many places you have to move forward? You have to move forward 6 places before. So you see 1, 2, 3, 4, 5, 6. So our answer is 0.009375. Clear all of you? If you see the sixth sum, 23 divided by 2 cube into 5 square. Students, in this you see here if 2 is having power 3 and 5 is having power 2. What I told you before in this problem itself, you have to see if the both the power is not same, you have to see the highest power. Who is having the highest power? 2 is having. What is the power? 3. Then this 5 also have to get 3. Isn't it? So here we are having 2. Still how many need we to get 3? Still we need 1 5. So that 1 5 we are multiplying and we are dividing. Okay, to get 5 cube. Okay, so 23 into 5 I am writing 2 cube. 5 power 2 plus 1 is what? 3. Here also base 5, here also base 5. So we can directly add the power. If the bases are same, the power can be added. So 23 into 5 is 115 divided by 2 into 5 whole cube we can write down. 2 into 5 is what? 10 the whole cube. So I have written 10 the whole cube. So 10 the whole cube means what is the answer? 1000. 30 we have to get. So I have written 1000. So how many places we have to move now forward? 3 places. Since we have 30, we have to move 3 places forward. See, 1, 2, 3. So our answer is what? 0.115. Here all of you students, now the 8th question. 6 divided by 15. I have written here solution. Okay, 6 divided by 15. If I cancel 6 divided by 15, what will I get? Both will go in 3 table as we seen in the first subdivision, isn't it? So the same only we are doing here. If you cancel 6 divided by 15, we are getting answer as 2 by 5. Only 2 by 5 we are getting. To get in the form of 2 power m into 5 power n, we have got 5. But still what we need? 2. So that multiply 2 to the numerator and divide the 2 to the denominator. Clear all of you? So if you multiply 2 2s are 4, 5 2s are 10. So what is the answer? 4 divided by 10? 0.4. We have to move only the one place forward. Clear? Similarly, the same model is 9th sum. 35 divided by 50. Students, how can you write 35? 7 into 5 you can write. Similarly, 50, how can you write? 10 into 5. If you see here, this 5 and 5 will what? It will become... See here, 5 and 5 we get cancel means remaining is what? 7 by 10. So 7 by 10 answer is what? 0.7. Student, with that our second subdivision is over. Still we have one more subdivision which is third subdivision. I hope you all understood up to first subdivision and second subdivision, isn't it? The simple, very simple concept. One thing you have to remember is if the denominator part is in the form of 2 power m into 5 power n means it terminates. If it is not coming in the form 2 power m into 5 power n means it is not terminates. Okay, and they are asking in decimal expansion means in denominator you have to get 2 power m into 5 power n, then both the power you have to get same. Okay, if power is not same, you have to make according to it you have to make some calculation and you have to bring it same and you have to do the find the decimal expansion. Clear? Shall we now see we are now going to see next third subdivision. Student, this is your third question. The following real numbers have decimal expansions as given below. They itself are given in decimal expansion. In each case, decide whether they are rational or not. They are asking us to decide whether each question is rational or not. If they are rational, suppose if they are rational, if we are saying means and of the form P by Q, it should be the form of P by Q. What can you say about the prime factor of Q? If you are saying it is rational, you have to say the prime factor of Q. Clear? Now we will go for the question. In this third subdivision, we are having 3 subdivisions. The first subdivision, second subdivision and the third subdivision. The first subdivision we will see 43.1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, students, if the question is in rational number, okay, rational number means from the first what we are learning, rational number means it should be in rational number. Okay, this is for your understanding I have written. Rational, this R denotes rational number. Rational number means it should be in the form of P by Q, where Q should not be equal to 0. Isn't it? We have to bring it in the form of P by Q. Okay, now we'll see. We have to move back the decimal backward. See how many places we have to move back? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we want to take the decimal, we have to write 10 power 9, isn't it? So we have to move 10 places backward. So we have to divide with 10 power 9, isn't it? Then next step, if you see here, this 10, how can I write? 2 into 5 whole power 9 I can write, isn't it? Then this 9 is for 2 and as well as for this 5. So now if it is rational because it is coming in the form of P by Q, and the Q is what in form? It is in the form of 2 power n into 5 power m, isn't it? Therefore it is terminating. We have to write. Terminating means what I have told you. It will at one point we will get the solution I told you, isn't it? So this number is what? It is terminating. Clear all of you? So you have to write in the bracket. For Q we can say that Q is nothing but the denominator part. For Q we can say that the prime factor of Q in the form 2 power n into 5 power n. 2 power, what is the answer here? 2 power 9 into 5 power 9. So we can say the first subdivision is terminating. Clear? Now see the second subdivision. 0.120, 1200, 12000, 12000 and goes on. Okay. Now see children, here only 10, the next 20, then 30, then 40 and it is going on. Okay. Which means what? It is not terminating. It is not repeating. Whether the same number is repeating? No, it's going extra. So which means we can directly by seeing itself we can say, since the decimal expansion is neither terminating, it is not terminating and non-repeating. It is not, again it is not repeating also. So the given real number is not a rational number. Why? We cannot able to write it in the form of P by Q, isn't it? Rational number means we have to write it in the form P by Q. Since we cannot able to write this in P by Q form, it is not a rational number. Therefore, we can conclude that our solution is what? It is an irrational number. Clear? If it is rational number, we have to say the Q prime factor of Q. Since it is the irrational number, that's all. Our problem is over. Clear? The last third question we'll see now. Now we'll see the third question, third subdivision. If you see the third subdivision, 43.1, 2, 3, 4, 5, 6, 7, 8, 9 and on top we are having one line. That line indicates what? Bar. Okay, that line indicates bar. Which means what? The same number one more time, the same number it will repeating or going on. Okay, which means the meaning is what is 43.1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. And it will goes on. Okay, the same 9 number will repeat again and again. That is the meaning of that line. Okay, so 43.1, 2, 3, 4, 5, 6, 7, 8, 9, which means what? Rational number means we have to get in the form of P by Q. Okay, since this number is what? It is non-terminating, isn't it? Because we cannot write it in the form of P by Q. So, Q, we can say that the prime factor of Q is not in the form. The denominator part we cannot able to write in the form 2 power m into 5 power n, isn't it? Therefore, it is non-terminating and the same number is repeating, isn't it? So, it is non-terminating and repeating, otherwise we can say it as recurring. Clear all of you? Students, with this third subdivision, chapter 1 is fully over. Real number is fully over. So far we have seen 4 exercises, isn't it? The first exercise is full of what? Euclid division lemma and Euclid division algorithm. The second exercise is full of fundamental theorem of arithmetic and finding the LCM and HCF using prime factorization. Third subdivision is full of third exercise. Exercise 1.3 is full of what? Irrational numbers we have learned. Then the last exercise 1.4 is what? About terminating, non-terminating, recurring, repeating. That we have learned, isn't it? So student, with this 4 exercise, our first chapter real number is over. Okay, now this part, in part 7, you are having some assignment. Okay, listen the assignment. Students, even if you see in part 7, exercise 1.4, I have written the first sum, isn't it? The same heading you have to follow for this first sum assignment. Okay, because it is very lengthy. So, you copy that heading for this assignment, first subdivision. Okay, that is your heading. Okay, without actually dividing, we have to find terminating decimal expansion or otherwise non-terminating expansion. In that first subdivision, I have done only certain problem, remaining problem I have left, isn't it? I told you before, the left problem is your assignment, isn't it? These are the left problems. This you are going to do as your assignment from exercise 1.4 first subdivision. Clear? Now, in that exercise 1.4 itself, second subdivision, you go through the video before and you see what heading is there. That same heading write for the second subdivision. Clear? Then this is not your book problem. This core problem is your own sum. Okay, you copy that second subdivision heading alone for this and see the method of that second subdivision and the same as like you do the assignment problem. Clear all of you? Students, so far I have given more assignment, only few of you are completing the assignment, remaining of you are not completing your assignment and still many of you are sending your classwork part. Okay, we don't need your classwork part, we need only a assignment part. So, take that assignment part photo and send it in the WhatsApp. Okay, students, when you are doing homework, you be clear about your concept. Okay, with this chapter 1, real numbers is over. We'll see in the next chapter in next session. Thank you so much, children.